In this video, I am going to describe a probability problem. The problem is like this. I start with a well-shuffled deck of 52 cards, a standard deck. Now what I do is I have all the cards lying face down. I will take each one of them starting from the top and make them face up. 1, 2 and so on. Now, after seeing some of them, you have to say the word next. The moment you say next, I will pick up only one more card and check if it is the ace of spades. If it is, in that case you win. If it is not, in that case you lose. So let's do it again. So I just shuffle it somehow. Suppose I shuffle it, because that's just symbolic shuffling. A true shuffling will require more effort. Okay, I turn it like this. 2 of spades. I turn another one, you are still silent. Okay, now suppose you choose to say next. I turn it around. It is not the ace of spades, so you lose. So that is one run of the game. Okay, now suppose I play it in another way. So here is again a well shuffled deck of cards, and what I do is like this. I show the first one and you immediately shout next. I turn it around and indeed it is the ace of spades, so in this case we have win. Now the problem says the following. It says whatever strategy you use. Remember, when I'm talking about strategy, I mean you can take a look at all the cards that have been turned so far, and based on that you may choose to say next or not. So whatever strategy you choose, the probability that you will have a win is going to be 1 over 52. So let's first use some particular strategy and see how it works. Suppose my strategy is I will always see 5 cards and then I will say next. That is one possible strategy. 1, 2, I already have ace of spades, but my strategy is say you have to look at 5 cards. 2, 3, 4, 5, and now I shout next. Of course, meaningless because I already know that I have lost, but my strategy says I have to say next, and I find this, which is not ace of spades, obviously. So I now say that I lose. Now one point is that there is one thing which is pretty obvious, and that one thing is the following. Suppose here is my ace of spades and that happens to be at the very end, the very last card. And I am not saying next. So I turn around, it goes on like this, and I have turned all these cards upside down. And still I have not found ace of spades here, I have not yet said next. Then obviously I know that this guy has to be the ace of spades, and obviously I will say next at this point. That is for sure. So you cannot have a strategy like I will never say next. That is not the case. So in this case you have to say next, and in this case you are going to win. So now we have to check if the probability for every possible strategy is 1 over 52 or not. Let's try to compute the probability for this particular strategy. The strategy is you see the first 3 cards and then just say next, irrespective of whatever you have seen in those 3 cards. To analyze this strategy, we consider the 52 cards. This is the first one that is turned up, the second one, third one. So after this, it is in this 4th card that we are going to say next. So how can we win in this strategy? If and only if this guy is the ace of spades. And what is the probability that this guy will be the ace of spades? Since there are 52 cards, so the total number of possible permutations is 52 factorial, and out of that we are considering all those permutations where this place is occupied by the ace of spades. So I have only freedom to choose the remaining 51. So my event size is 51 factorial. So the probability is 51 factorial by 52 factorial, and that is indeed 1 over 52. Now I need to show that this will work not just for this strategy, but whatever strategy you may have in mind. So let's take a look at a slightly more complicated strategy. The strategy we now consider is this. I will say next the moment I see a club follows a heart. So if I ever see a heart club being followed immediately by a club card, I will at once say next. Pretty meaningless stuff, but that's a strategy. Now you have to understand what happens if in the entire game never does a club follow a heart. Suppose it never occurs. What do I do then? Then we will think about it in the following way. I am seeing the cards one by one, goes on and on and on. I have come to card 51. So I have seen all these cards, and suppose I have not seen a single case where a club immediately follows a heart. Also, I have not seen the ace of spades so far. So since my strategy is to say next, if this happens, when I say if, I actually means if and only if. So I have not said next so far. I have not seen the ace of spades so far. Now I am damn certain that it has to be here. So it will be very stupid of me if I do not say next at this point. So in that case, I do say next if I come to the 51st card, I have not seen the ace of spades ever, then of course I will always say next. I am not specifically mentioning that in my strategy. So that is always there. But I may possibly stop beforehand if a club follows a heart. Now suppose what happens if we get the following situation. I have this strategy and I never see club follows a heart, but in the third step I have already seen the ace of spades. In that case, of course, I will go all the way through. I will never say next because I know that I have lost the game. So I am never going to say next. So clearly understand this. Whenever I say strategy, the thing that I write down is the rule. When I say next, if I am before the 51st card, before or at the 51st card, if I am at the 51st card, I have not said next yet, and I have not seen the ace of spades, then goes without saying, I will say next. That is always given, and I am not writing that separately in the strategy. So now let us see what is the probability that this particular strategy will win. For this, we first fix any permutation of the remaining 51 cards. So in order to get a full permutation of the deck, I just have to insert the ace of spades in one of these places. So there are 52 places where I can put my ace of spades. And I want to see out of all these 52 cases, when am I going to win? Suppose here is one possible permutation of those 51 cards. I start with a spade, then I get a heart, another heart, and I get a club. So this is the first point where I get a club following a heart. So immediately I am going to say next. So I will win if and only if I put my ace of spades in this position. That is the only way I can win it. In other words, I should say, because I wrote only 52, if and only if I insert my ace of spades between the fourth and the fifth card, because the cards that I have shown as lines, they are the other 51 cards. So I will win if and only if I place it here. You understand this? Instead of working with all the possible things, I fixed one permutation, which means now I am dealing with only 52 possible cases, depending on whether the ace of spades is here or here or here or here or at the very end. Out of these 52, I see that I am winning if and only if I insert it at this point. So out of 52, only one leads to a win, under the case where I have the club following a heart in one place. Okay, now suppose that I have a particular permutation where club follows heart never occurs. In that case, I go on and on and on, and I never see club follows heart. So I will never say next, never say next. Now if my ace of cards I insert here, then obviously I am going to lose, because I will never say next. I will go all the way up to this and still I will not say next. So the only way I can win in this case is if I insert my ace of cards right at the end. Only then I can win. So again, you see, if you fix a permutation where club follows heart never occurs, even then out of the 52 possible places of inserting the ace of spades, only one is going to help. Only one is going to lead to win. So again it is 1 out of 52. And this is true for all possible permutations, right? I have shown for all permutations for which this occurs and all permutations for which this does not occur. Which means for every possible permutation of the other 51 cards, I always find that exactly 1 out of 52 possibilities leads to win, which means out of all the 52 factorial possible permutations, exactly 1 upon 52 part of it will lead to win. So the probability that this strategy leads to win is 1 over 52 as claimed in the problem. Now we want to show that this 1 upon 52 probability holds for any general strategy. And that brings us to the question, what is a general strategy? A strategy may be very, very complicated. It could be something like, if I see a composite number exactly 3 cards after a prime number, and if the entire thing happens without any intervening heart card, then I will say next. You can make things as complicated as you like. So how do I do a general proof? So for this, you first understand that when we have a strategy that is basically characterized by a set of card sequences. For example, if I say that I will always say next exactly after seeing 2 cards, in that case my set of card sequences consists of all possible double turn sequences. So the moment I see any sequence in my set, I will say next. And if I say that I will say next whenever I see, say, 2 of spades, in that case my set of card sequences consists of all those sequences which end with 2 of spades. So the moment I see 2 of spades, I will say next. So you understand, a strategy is uniquely determined by a set of card sequences. For instance, if I give you this set, this means if I see a 5 of spades at the very beginning and then I see 2 of clubs, immediately I will say next. Or if I see at the very beginning king of hearts, then I will wait for 2 cards. I do not care what those 2 cards are. immediately I will say next. So if either this occurs or this occurs. So you see, though I write it as a single sequence, it's not a single sequence because I am using stars. So it's actually lots of sequences, all sequences of length 3 starting with King of Hearts. So this will give me one possible strategy. Now, whenever I say my strategy is characterized by such a set, you should understand that if none of these things occur for the first 51 cards, so I have not said next, and the Ace of Spades has also not occurred among those 51 cards, then definitely I am going to say next. That is not given in this sequence because that is always there. So you have to understand that this set is only to deal with the other cases. Now consider this particular set of sequences. Can this be a valid strategy? No, because this says if you see S5 followed by C2, that is the very first card is S5, then you have a C2, you say next. This one says if you have S5 and C2, you still continue. When it is after that you get Ace of Hearts, then you say next. But these two things are contradictory because if you have already said next here, you will never come to this. So you see, in your set of sequences, no sequence must form the first part of any other sequence. Typically, we say that this sequence is a prefix of this sequence. So, no sequence must form a prefix of any other sequence. Of course, it forms a prefix of itself, I mean of any other distinct sequence in the set. Because these two things will be contradictory. This one says you have to wait up to H1 and this one says you already said next. So now you understand what is meant by a general strategy. A general strategy is a set of card sequences such that no sequence there is a prefix of any other distinct sequence. Now is it possible that this set gives you a strategy? This says if you see that the very first card is the Ace of Spades, then you say next. So you think that if the first one is Ace of Spades, then the next one should also be Ace of Spades. Stupid. Similarly, in this case, you have already seen Ace of Hearts, then Ace of Spades, then Two of Clubs, and now you believe that the next one is going to be again Ace of Spades. So that puts a natural condition on your strategy set. Your strategy set must contain at least one sequence which does not mention the Ace of Spades. That's a very natural condition. In particular, the empty set also cannot be a valid strategy set. So now you have an idea about what is meant by a general strategy. Now suppose I give you a general strategy B. By this I mean a set of sequences. Now I have already mentioned that having a sequence which already contains S1 in it is basically useless because those sequences can never lead to win. So you might as well think that all those things are dropped. Now I want to show that for this particular strategy B, the probability of win will be 1 over 52. And the way I will prove it is by first fixing a permutation of the other 51 cards. Then a permutation of the full deck can be obtained by introducing Ace of Spades in one of these 52 gaps. We have already seen this argument in one of our examples that I gave initially. So it can be put here, it may be put here, 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 or at the very end. So 52 places. I shall show that out of these 52 possible permutations, only one will lead to win by using this strategy. Now I have already said that I have thrown away all the sequences here that contain S1. Now see if there is any sequence here that occur here. If there is any such sequence, that means that you will say stop at that point if you do not have your S1 up to that point. So you are going to insert S1 in some place. For the time being, let's pretend S1 is not there. You are just applying this strategy to this. Now, because of that prefix condition, if some sequence here matches the initial part, that must be unique. You cannot have more than one thing matching, because otherwise your strategy will ask you to say next in more than one places. So let's pretend that you have the sequence C1, C2, S5 in this set. That means that one of your strategies is that your strategy is, if you ever see C1, then C2, then C5 right at the beginning, you will immediately say next. Now, if that is the case, are you going to win if you insert S1 here? No. Are you going to win if you insert S1 here? No. Here? No. Here? Yes. That is the only place where you can insert your ace of spades and guarantee a win. So look at that particular unique sequence that occurs here in this permutation. The sequence has to be unique, and the only way you can guarantee win is by inserting your S1, ace of spades, right after that sequence. If you insert your ace of spades elsewhere, then also you are not going to win. So we have shown that if the permutation that you have fixed satisfies this property, that part of the initial thing exactly matches one sequence in your set, in which case it has to match a unique one of your set, then out of the 52 possible places where you can insert S1, exactly one will lead to win. Now consider the other case. You have fixed a permutation which does not click with any of these sequences. It never occurs. In that case, you will not say next for all the first 51 cards, and you know by our default strategy that if that is the case, you are going to say next at the very end. Thus, if you insert your ace of spades at the very end, you are going to win. And obviously, if you insert your ace of spades anywhere in between, according to this criteria, you are never going to win, because you will never say next. So, in this case also we find only one possible insertion point out of the 52 insertion points is going to work. So, out of all the possible permutations, only 1 by 52 proportion is going to lead to a win. Hence, the probability of win with whatever strategy you have in mind, that is whatever reasonable strategy, we put those reasonable conditions, that will lead to probability of win 1 over 52. You can of course think of a stupid strategy like I will never say next, I will always remain silent. Then that of course has probability 0 of win. But other than that, or you can, if you say I will say next only when I see the ace of spades, only then I will say next. That's also another stupid strategy. But if you are not using those stupid strategies, so the restriction is there must be at least one sequence which does not explicitly contain S1 in it, then we can say that the probability of win has to be 1 over 52.